Well, good afternoon, everybody. My name is Michael Free, and I'm the Vice President of Sales and Marketing for Terra Systems, and I'll be today's moderator for the presentation, Combined EVO and ZVI for Enhanced Remediation of Chlorinated Solvents. Just a couple of housekeeping items. As we go through the presentation, I'm going to leave everybody on mute, but if you have a question on a particular slide, if you could put it up in the message, which is the bubble up next to the people. And then at the end, I'll go through those and ask Mike or Paul to address the questions for you. Also, if you find the webinar useful and you'd like to organize something within your own company, we'd be glad to, do it for a particular company if you'd like to pick a particular time or day, and just send me an email and I'll take care of that. So I'm going to introduce the two speakers for today. Dr. Mike Lee has a PhD from Rice University in environmental science. He has 30 plus years of experience in the field of bioremediation, and he was the technical lead for the first successful demonstration of bioaugmentation to promote the complete anaerobic biodegradation of TCE and cis-DCE for the Remediation Technologies Development Forum at Dover Air Force Base. He jointly holds the first U.S. patent for the use of emulsified soybean oil to support the complete reductive dechlorination of chlorinated solvents. Paul Dombrowski is a senior remediation engineer with Isotech who has over 16 years in the environmental industry with a focus in designing and implementing in situ remediation technologies. Paul's experience includes 12 plus years in consulting and 4 plus with Isotech. In his spare time, Paul is an adjunct lecturer at Tufts University in Medford, Massachusetts, and I believe he also runs marathons. I'd like to tell you a little bit about Terra Systems. We were founded in 1992, and we've been in continuous operation for greater than 28 years. We have a worldwide footprint with production in the US and Japan. Mike Lee and Dick Raymond, the president of Terra Systems, were involved in the first field demonstration of anaerobic bioremediation of PCE at the DuPont Victoria plant in Victoria, Texas. You see a list of our manufacturing core competencies. What I'd like to do is just mention one of those, which is our manufacturing core competence, which you'll hear more about later on. We're capable of creating customizable blends of carbon substrates, iron, and nutrients, which Isotech and other consultants have taken advantage of. We often say that remediation is a contact sport, and success requires bringing amendments and contaminants together. Isotech are remediation specialists with experience implementing and designing. Sorry, got to flip slides here. A broad range of remediation technologies, including chemical oxidation, bioremediation, chemical reductants, and combined remedies. Isotech brings technical experts and experienced field staff to project design and implementation, and they provide nationwide coverage and have a stellar safety record with 0 OSHA reportable incidents in their 25 plus year history. So that's the end of the commercial break, and what I'd like to do is turn it over to Dr. Mike Lee.
We're talking today about in situ bioremediation and also abiotic biodegradation or degradation of chlorinated solvents. Many have seen this pathway for the anaerobic biodegradation of PCE, tetrachloroethene, to trichloroethene, to cis-dichloroethene. We generally don't see much of the other isomers of DCE, the 1,1-dichloroethene of the trans-DCE. Under biological conditions, predominantly it's cis-DCE, and then it's further transformed to vinyl chloride, and finally to the innocuous products, ethene. Occasionally, we do see some ethane being produced, further production of the double bond to a single bond to form ethane. A lot of different organisms can carry out the first 2 steps, the PCE to TCE to DCE, but only a couple of organisms have been found so far that can break down the dichloroethylene and vinyl chloride all the way to ethene, and those are Dihalococoides and dehalogemonas. And if those organisms aren't present or conditions aren't favorable, then you may see a cis-DC or vinyl chloride stall. Next slide. So some of the products that Terra Systems manufactures are for slow release, our substrates. It's our family of emulsified vegetable oils. As Michael said, we can manufacture those in a variety of droplet sizes with a variety of emulsifier packages. Our standard product has a non-ionic surfactant, but we can also make products with an anionic surfactants that are more sticky for high groundwater flow rate situations. And we also can customize the nutrient form packages. Most of our products have quick release substrate, sodium lactate, as well as inorganic and organic nutrients and vitamin B12 standard. We also have a line of quick release substrates, the sodium and potassium lactates, again with a variety of nutrient packages. And then what we're talking about today is our biotic and biological substrates, the SRS ZVI family of emulsified vegetable oil in Zero Valent Iron. We have 4 primary particle sizes that we use. We can do a variety of oil and ZVI configurations and nutrient packages. And then we also have a dechlorination culture that we sell, Dihalococoides and Dihalobacter. Next slide. So when you combine EVO and ZVI, you're going to get the EVO in ZVI at the ejection points, and then further down gradient, you're going to have dissolved organic carbon. And you're going to see a little different pathway for the degradation of the chlorinated solvents. Typically, you don't see nearly as much of the daughter products, and you may see production of products like dichloroacetylene or chloroacetylene, and finally conversion to acetylene. Oftentimes, those products are transitory, and you may not ever see them, particularly the dichloroethylene and chloroacetylene aren't on your standard VOC list. One of the other distinguishing factors of the abiotic process is you don't produce nearly as much of the cis-DC and vinyl chloride. You do sometimes see ethene, ethane, and acetylene all being produced by the abiotic reactions. Next slide. So Terra Systems has 2 primary ZVI oil combinations. The SRS EZVI, which is under the NASA patent. It's a mixture of soybean oil, 10 to 17% of the ZVI. Typically, we're using a small ZVI that's highly reactive. It also includes water and a surfactant. We're using either a 2 or 3 micron ZVI suspended in glycerol, often with a sulfidation process for enhanced reactivity and longevity, or a 4 micron ZVI powder. And this material is injectable into wells or by direct push. The other product that we sell is the SRS ZVI. It's licensed under the IET patent. It includes soybean oil, surfactants, sodium lactate, organic nutrients, inorganic nutrients, and vitamin B12. So it's our standard SRS package. And then we can customize the amount of the ZVI from 10 to 40%, and also this particle size. We've typically used either a 2 or 4 micron material or less than 44 and less than 125 micron ZVI particles. We can incorporate ferrous sulfide again for their enhanced reactivity and longevity. And we recommend direct push injection, particularly for particles that have greater than 4 micron ZVI. Next slide. I'm going to walk you through a couple of case histories where our materials have been applied. The first is at upstate New York Airport. It's a former fire training pit. The geology is an overburden and fractured bedrock. 2 injections were performed in 2015 in the first one, with about 5,000 pounds of the SRS and 600 pounds of the 2 micron ZVI. Treatment volume is about 44,000 cubic feet. And then a follow-up injection occurred in June 2018 of about 20,600 gallons of the combined product. Next slide. So there are 2 different pathways that I wanted to point out. In the upper side, well, MW10-1DA, we're seeing more of a biotic signature. We're seeing the cis-DC being converted to vinyl chloride, and then all of it's going away. In that particular well, we saw about a 98.7% removal of the chlorinated ethenes on a micromolar basis. And again, everything here is on a micromolar basis. And then the following well, PW10-2E, we're seeing more of an abiotic signature, probably where we're closer to the ZVI injections. And we're seeing a simultaneous reduction of the cis-DC vinyl chloride. And here we see it's about a 96.4% removal of the total chlorinated ethenes. Next slide. The next project is a groundwater site in North Carolina. It's a very high groundwater flow rate of about 6 feet per day. It's sandy soils. Several different injections have been conducted there. It was a pilot in March of 2015, followed up by full-scale injections in September of 2015, and then another full-scale injection in 2017. We point out the area over in black is greater than 100,000 micrograms per liter of TCE. So it's very high concentrations of DCE. The loading rate here was about 1.1% of the SRS ZVI, with 125 micron ZVI particle, and about 0.9% SRS. Next slide. So this shows the results for one well, MW6. We're seeing conversion of the TCE rapidly after the injection of the material shown in the black line, with production of some vinyl chloride, and then out at about July of 2018, we're seeing a good bit of ethene. Overall, we're seeing a 93.1% removal of the chlorinated ethenes over this treatment period. And we're seeing TOC concentrations coming up to almost 12,000 milligrams per liter, some point after the injections, and this sustained release of the TOC above 2,000 milligrams per liter for over 2 years. Next slide. So this slide shows the percent removal of the chlorinated ethenes. You can see the injection wells shown in the black. The red ones are the subsequent injections in 2017. And we're seeing very good removal within that treatment area for most of the wells. Remember, we started at over 100,000 micrograms per liter of TCE, and we're down to at most 18,000, and many of the wells were down to much lower concentrations of TCE. Overall removal shown in red were very good for most of the areas, 93, 99%. Then a couple of wells showed a little bit less, like MW13, kind of in the middle of the screen. Overall hasn't shown as much removal, but probably need to come back to follow up with additional treatment in that area. And the wells outside of the treatment area are surely really showing no improvement, like MW21 and MW22 up at the top that weren't treated with the products. So very good removals of the chlorinated ethenes at this site. Next slide. I'm going to turn it over to Paul Dombrowski.
All right. Well, thank you, Mike, and thank you, Michael, for the introduction. I'm going to talk in this presentation. We're going to focus on 3 case studies where EVO and ZVI were used together, and each of these sites has a very different geologic setting. So the first site is a site where the soils are primarily glacially compacted, fine-grained sands. So as a result, this is overburdened, very low permeability soils. In evaluating different technologies, Isotech collaborated with the client and the consultant and to evaluate different approaches, and a enhanced reductive dechlorination approach was selected, looking to have a technology that was going to have a persistent ongoing treatment. And we selected emulsified vegetable oil with zero valent iron. Next slide. So we started with a pilot test, about 900 square feet in area, focused on where the highest concentrations had been observed on site. We looked at 9 direct push intervals using direct push injection. There was a spacing of about 11 to 12 feet in between points based on different access and the like. And we injected using Isotex laser cut stainless steel screens, which are shown in the photo on the right. These screens are approximately 1 centimeter in diameter and have 10 slot openings sliced into to allow 360-degree flow all the way around. And in our experience, we're able to inject the EVO ZVI with the ZVI in the 2 to 4 micron size, relatively low pressures. In our experience, that's anywhere less than 10 psi, maybe to about 40 psi maximum, and a lot of that more has to do with the geology than the actual screen size. And our screens, they're available in lengths of 1 foot to 8 foot in 1 foot intervals. And we choose screen sizes based on the site geology, and we will often even use different screen sizes across a given site based on what the stratigraphy is telling us. Next slide. So for the project, we chose a combination of SRS-SD, which is the small droplet EVO, chosen for the very fine grain, low permeability soils, and using SRS-ZVI with 2 micron ZVI and with the small droplet SRS-SD product. We also included KB1 as the Dechlorination bioaugmentation culture with pH buffer. And as luck or bad luck would have it, a snow squall came through right during our pilot test, which made for difficult working conditions, but also for a good photo shot. Next slide. So here are the preliminary results. This is from sampling 2 and 4 months post-injection. And this top plot here is the monitoring well 401, which is right in the middle of the pilot test area. This well had a concentration of 50,000 micrograms per liter in the sample collected shortly before the injection. And then 4 months after injection, the TCE had been reduced to 20 micrograms per liter. And we're generally seeing very limited reductive dechlorination daughter products, the DCE and the vinyl chloride. So this well showed a very strong abiotic dechlorination signal and shows just how quickly and how significantly the use of zero valent iron with the EVO can achieve reduction in your high concentration of chlorinated solvents. This bottom plot is a well that's located approximately 10 feet down gradient of the injection area. So here we're seeing as the organic carbon is migrating over time, we didn't see any reductive dechlorination or change in TCE 2 months after injection, but 4 months after injection, we saw a rapid decrease of TCE with a strong increase in the cis DCE. So here we're seeing biotic by the bacteria reductive dechlorination. And so given these results and how clearly and rapidly the reductions happened within the pilot test area itself, this project went to full scale in fall of 2020, and we're anxiously awaiting and excited to see our sampling results during the first half of 2021. Next slide. And just one other interesting note about that project, there's a soil vapor extraction system that's operating immediately above our pilot test area. And it was very interesting to see that there was an inflection point in the CVOC extraction rate in terms of pounds per day right after our injection was performed. And in addition, we're seeing a larger fraction of non-TCE VOCs in the extracted vapors after the pilot test than before the pilot test. So this just shows we're also resulting in reduced CVOC collection by the SVE system. Next slide. So the second case study is a project in New Jersey where there's both chlorinated ethenes and chlorinated ethenes that have impacted bedrock groundwater. As we can see on the right side, their concentrations very high, 10 to almost 40 milligrams per liter for the individual chlorinated VOCs. The bedrock here it's sedimentary and it's primarily consistent of shale and sandstone. And as a result, the groundwater flow is primarily in the secondary porosity, the fractures in the bedding planes. At this site, there had been various pilot tests performed over time, and given that reductive dechlorination was chosen as the full-scale approach. Next slide. So for this side, the client consultant selected a remedy of in situ dechlorination for the source area, where the concentrations were highest, and longer-term mononatural attenuation in areas that had groundwater impacts, further downgradient of the source area. The project objectives, the immediate objective was to reduce all CVOC concentrations below 1% of DNAPL solubility. Again, we're focused on reducing the concentrations in the source area, but other objectives included establishing natural attenuation conditions that would support a reducing trend over time, and to achieve those conditions both in the wells in and around the source area, but also downgrading of the injection area. It was desired to have mononatural attenuation conditions established and observed. And this client also had interest and a desire for sustainable remediation processes to be incorporated into the project. Next slide. So when Isotech was looking at the request for proposal for this project, we thought, how are we going to achieve the best reduction in concentrations, the high concentrations, as well as to establish mononatural attenuation for the site. And we elected to go with a series of liquid ERD amendments. And we wanted amendments that would in carbon substrates and that would continue to migrate after injection. And also we wanted amendments that can be injected at relatively low pressure. In this case, we wanted to preferentially deliver the amendments into the existing bedding planes and fractures where the high concentrations of CVOCs were located. In contrast to other amendments that may be slurries that are injected at much higher pressures, which could actually create new fractures where CVOCs were not located. As Michael noted at the top of the presentation, really contact is the most important aspect of any successful remediation. So we wanted to make sure that we could deliver the amendments that were going to do the remediation to where the contaminants are located. And we also we're going to incorporate inflatable packers so that we can target identified fractures where the CVOCs were located. And we also propose to use multiple ERD amendments, which I'll describe further on the next slide. So Isotech proposed to use a series of amendments and inject them sequentially. So the first step was injecting sodium lactate as a quick release substrate. This was selected to accelerate the process of establishing reductive conditions in the source area, in the injection area. The second sequential step was a small droplet EVO, the SRS-SD. And with this, we wanted to have a longer term carbon substrate that also had a higher potential for migrating throughout the injection area and further afield to further allow natural attenuation, reductive conditions outside of our injection area. And the third component was SRS-ZVI using a large droplet EVO. So this had a large droplet EVO and a 2-micron ZVI. And this was selected because we wanted to keep the ZVI and EVO as close to the injection wells as possible. The injection wells were right in the area with the source area, so we did not want that EVO to migrate outside of that area. We wanted to have a long-term, persistent carbon substrate that would establish ongoing reductive dechlorination. In addition, we use a series of pH buffers that are both quick and longer lasting, as well as bioaugmentation with D-alkycoides and D-halobacter for both the chlorinated ethenes and chlorinated ethanes. Next slide. The injection program itself used 12 injection wells. These wells were open boreholes 4 inches in diameter that were drilled to 55 feet. And we use straddle packers to identify the fractures of interest. In general, all of the injections were performed at 10 to maybe a maximum of 70 psi, which is a relatively low pressure when you're dealing with bedrock and at 50 to 60 feet below ground surface. Next slide. And so these are results we have thus far. So to date, there's been 12 months of post-injection, and we see on both of these plots to the right, very rapid reduction of CVOCs, including the wells that had very high concentrations, to the point where we are achieving 99% reduction in multiple wells in the injection source area, which given that it was bedrock, given the high concentrations, given the potential likelihood of some non-aqueous phase liquids, this exceeded even my best expectations. So we're quite pleased with the results so far. And we're also seeing some lines of evidence of biodegradation products, in particular the DCE, vinyl chloride, and a little bit of 1,1-DCA. And we can see that in this orange line here, which is the cis DCE, which in the bottom increases and then subsequently decreases. Or in the top slide, you see that the slope it doesn't correlate with the other parent compounds, which are more of an abiotic. So we can see that there's a decrease, but it's also a slower decrease because we're seeing production over time. And as noted, within the whole treatment area of the monitoring wells that are there, to date, 70 to 99% reduction in the total CVOCs. Next slide. As I mentioned, the client had great interest in incorporating sustainable remediation into various aspects of the project. And one of the primary ways that Isotech achieved this was with our reagent selection. And Isotech worked very closely with Terra Systems to have a smaller footprint environmentally for our amendments. And notably, the Terra Systems facility was located less than 90 miles from the site. We used a similar approach of ZVI and EVO on another project this year, and using and those amendments were shipped from facilities in the upper Midwest. So that that distance is 600 to 900 miles, and so significantly more trucker miles and emissions from that. We were also able to have all of the amendments. All three of those amendments that were used, they were delivered in a single delivery, so there was just one truck. And Terra Systems also procures soybeans from mid-Atlantic farmers. There's a big push now of farm-to-table dining. Well, this is farm-to-ground remediation of knowing where our soybeans come from and reducing that distance from farm to field. And as a result, Terra Systems was able to offer a zero carbon footprint certification for this project and all the amendments. For our subcontractors, Isotech identified deliveries and other subcontractors as close as possible to the site. The drillers, a very local driller, our rentals of fence and a Conex box. The supplier was actually less than 5 miles from the site. So we were able to minimize our driving distances for any of our deliveries and subcontractors. We had a no idling policy for all vehicles and equipment on site, and Isotech typically does, but we made extra efforts to reduce the usage and having them on when they were not needed. That was for the forklift, for our compressors, and the like. And we also did it through our day-to-day transportation. Typically, Isotech would have our staff meet at the site, at the office, and drive to the site in a heavy-duty pickup truck. Well, we had procured a fuel-efficient small SUV, and staff, this is pre-COVID, were carpooling together in a less gas usage vehicle. And some employees were driving to the site directly from their house, and that was a shorter distance than going to the office as well. So looking to how did we minimize our miles driven to the site for all of our employees. And finally, all of the totes and drums from the project were recycled. Next slide. And the third case study I'm going to present on is a site where chlorinated VOCs were known to be located in bedrock and weathered bedrock. There was a historic multi-phase extraction system with these wells screened in the weather bedrock and the bedrock, shown in the black bars to the right. And when Isotech was first looking at this site and working with the consultant, we noticed that there was very high PID readings in the deep overburden in the multi-phase extraction wells when they were installed almost 20 years ago. And to that, we saw that there was likely residual TCE still in the deep overburden in the zone that was not being extracted by the extraction wells. So that was an area of focus that we wanted to look at. So starting out, it was proposed to do a small pilot test. It was only three points, but we focused on the interval right at the bottom of the sandy silt and the top of the weathered bedrock. This is a New England site. In our experience, we have several sites where a direct push drill rig could advance some distance into weathered bedrock just by pushing. And we wanted to evaluate if that was the case. And in our 3 points, we were able to advance anywhere from 6 inches to 2 feet into the weathered bedrock. And in that case, then we injected. So we first injected a small narrow interval. This is using the Isotech laser cut injection screens that I showed on a previous slide. And first injected, just focused in on the weathered bedrock. And then we had an injection interval immediately on top of the weathered bedrock. So here on the lower right here, we're looking at the monitoring in this well that is screened entirely in the weathered bedrock nearby. And as we can see, there's quite a noticeable seasonal fluctuation between the spring and the fall sampling between with the TCE concentrations. But then if we look 12 months after the injection, the TCE has dropped to the lowest concentration that it's been recorded at in at least the last 10 years. And that we also saw a increase in the cis-DCE followed by subsequent decrease. And we're also seeing elevated concentrations of ethene in the 200 to 300 microgram per liter range. Next slide. And this is the bottom plot here is showing a well that is screened in both weathered bedrock and competent bedrock. This well, as recently as 2018, had a detected concentration of 142,000 micrograms per liter, so likely some non-aqueous phase liquid in this zone. Also seeing the seasonal fluctuation, but with the TCE. However, 12 months after the injection, TCE is 94% lower than it was in the fall of 2019, 1 year earlier. And note this is on a semi-log plot. And there was a initial increase in the cis-DCE with a subsequent decrease in the cis-DCE as well. So we're seeing both abiotic and biotic signals in these monitoring wells, but also accompanying that significant reduction in concentrations that is quite rapid. Next slide.
So this is kind of a summary of a number of the sites that we've talked about today and a few others, showing the geology that we've injected into the treatment areas, and then the loading rates of the ZVI ranging between the low of about 0.0039% up to a maximum of about 0.68% by weight. And then the loadings of the SRS, again, ranging from a low of 0.0058% in Oklahoma up to a maximum of 1.6% at the North Carolina site. And we're seeing very good removals in most of those zones. A couple of the wells, like sites in the site in North Carolina, maximum removal or average removal is about 33.8% with a maximum of 99%. So there's a couple of wells that need an additional treatment. But overall, we've had very good results with the ZVI products and been able to deliver them into a variety of geologies. Next slide. At this point, we'll wraps up our presentation, and we'll be able to take some questions from you.
Yeah, this is Michael Free, and if I've got a couple of questions, but before we go to that, again, if you have a question, feel free to use the chat function. and I'll, try to address them if I think they're of general interest. If they're not, I'll have Mike or Paul, respond directly to you. But one of the questions, well, first of all, Mike and Paul, thank you very much for the presentation. And one of the questions, and I'll put it to both of you, both from a technical standpoint, Mike, and then Paul, maybe more from a practical field standpoint. So we've been talking about the combination of EVO and ZVI today, but people inject EVO by itself and people inject ZVI by itself. So from a chemistry standpoint, Mike, the question is, why, or are there situations where you should just use straight ZVI powder versus combining it with EVO? And then Paul, from a practical standpoint, are there reasons to do the ZVI by itself versus, combining it with a liquid amendment? So Mike, from a technical standpoint, I mean, what would be the advantages or disadvantages, I guess, of ZVI by itself versus?
Well, the ZVI itself is going to promote the abiotic degradation reaction. The advantage of combining the two products, the SRS or the EVO and the ZVI, is that you get better distribution in contact with a wider treatment area than you can probably achieve with just the ZVI alone.
So what kind of, for comparison purposes, and maybe this is more for Paul, injecting, just ZVI powder versus the EVO and ZVI, what's your experience in terms of, distribution?
Right. I'm trying to think if how to compare those. I mean, for one, you can't overlook just the cost difference. So I mean that may be a reason for one or the other. EVO is an amendment that has been demonstrated for many years to be very, very effective at enhancing reductive dechlorination. It's long lasting, which to me that's one of the key benefits of it. And I mean, with the ZVI, in and itself, there's so many different amendments on the marketplace these days, and they are of different sizes, different carrying agents. So that's something you need to think carefully of. But I think I hadn't maybe thought about ZVI only versus EVO, but Mike's point I think from my experience is valid in that by having the ZVI in the EVO, it is going to support the overall distribution and get that EVO away from your injection well, distributed into the aquifer. In terms of just a real benefit of having them together, I think it really does come down to taking both of those amendments, which are very effective in themselves. And so EVO, it's very effective reductive dechlorination, but you have daughter products that have to be worked through. And the bacteria can usually do it, but it takes some time. So if you can, the combination with the ZVI, if you can reduce those daughter products or reduce how many are, it'll reduce your overall treatment time frame. And so I hope that answers some of those questions, Michael.
Yeah, no, I think those are all, valid points, and it depends on, of course, the geology in each individual site. I mean, I think your bedrock example was a good one, just illustrating that, you don't necessarily approach the site with a single amendment, and that you had objectives, you and your client had objectives for each of those amendments and what they were going to accomplish for you.
Right.
I don't see any other chat questions at the moment. So if you have any specific, you're shy and you have any specific questions that you would like to send Mike or Paul, their emails and phone numbers are up on the screen. If you have a particular site that you'd like us to take a look at, Mike Lee gets involved in a lot of pre-sales where he looks at the site data and helps the consultant, come up with an effective solution. And as I mentioned, if you found the presentation useful today and you'd like to share it internally at your company, we'd be glad to set something up, for you at a specific time, specific day. So with that, I'd like to thank everybody, and we'll keep you posted. Oh, okay. We do have another question about the slides. If you could... Actually, I don't remember what we did on the one the other day, guys. Did they send us a request, or are we just sending out the slides? Dick, are you on that you can unmute for a second and tell me?
I'm on. We'd like to have a request for the slides, and we'll be more than happy to provide them.
Okay, so I think most of you have John Raymond's email from the invites. You can send him a note, or feel free to send me a note at mfree@terrasystems.net, and we'll be able to, get a copy out to you. Great. Well, thank you very much, everybody. Appreciate your attendance today.
Thank you for attending.